Welcome to module 27. In this module, we'll discuss about distribution of functions of random variables. So we have the following setup. So let x equal to x1, x2, xp be a p-dimensional, either discrete or absolutely continuous random vector. And suppose fx is either the PMF or PDF of x. Suppose g is a function from Rp to R. Now, in many situations, we may be interested in knowing the probability distribution of random variable y, which is g of x. So what we are going to discuss in this module is how to find the PDF or PMF or distribution function of y is equal to gx. So to see why such a situation would be useful, suppose you have a company which manufactures electric bulbs. Past lifetime experiments on electric bulbs suggest that the lifetime of randomly chosen electric bulbs manufactured by company can be described by a random variable x, which has a PDF of the following form. So fx given theta is 1 by theta e to power minus x by theta x greater than 0 and 0 otherwise. However, this parameter theta greater than 0 is unknown. Now, to obtain information about unknown theta, a live testing experiment was conducted on n electric bulbs independently. So suppose xi is the lifetime of the ith bulb. Note that this is a random variable which we do not know in advance what value it will take. So it is a random variable, and what I have is I have n lifetimes with me x1, x2, xn. So what we have is x1, x2, xn. This is a collection of independent and identically distributed random variables. We call a collection of IID random variables as a random sample. So whenever we say that we have a random sample, what it means is we have a collection of independent and identically distributed random variables. Now in this example, it can be easily seen that expected value of x is theta. So basically expected value of each xi is theta, because each xi is a random variable. So a natural estimator of theta would be the sample mean. So I try to estimate theta by the sample mean, which is 1 upon n summation I is equal to 1 to n xi. Now to study how this good estimate x bar is, we may need the probability distribution of x bar. So here I am interested in the probability distribution of function of x1, x2, xn, which is given by x bar, which is 1 by n summation I is equal to 1 to n xi. So let me give the following definition. Now a function of one or more random variables that does not depend on any unknown parameter involved in joint PMF or PDF of random variables is called a statistic. So a statistic is a function of sample observations only. So it should not depend on any unknown parameter which is involved in the probability distribution function or probability mass function. And a collection of IID random variables is called a random sample. That is what we explained a few moments back. So in the above example, for example, x bar, which is a function of x1, x2, xn, is a statistic. x1 alone, which only depends on x1, is a statistic. x1 plus x2 by 2 is also a statistic. However, if I consider x bar minus theta, then it is a function of sample observations as well as unknown parameter theta. Or similarly, x1 by theta, which is again a function of sample observations and unknown parameter theta, they are not statistics, whereas these three quantities are statistics. So now we will discuss various techniques to find the probability distribution of random variable y, which is g of x. What we know is we have x1, x2, xn, a random sample. Basically what it means is it is a collection of IID random variables. So we will see how to find the distribution of y is equal to gx. So the first method is you first try to find out what is the distribution function of y is equal to gx. So the distribution function of y is equal to gx can be determined by computing the distribution function of y is equal to gx. And then using the distribution function, I can find out what is the probability mass function or probability density function of y. To illustrate how it works, let x1, x2 be a random sample from a distribution having PDF fx. So that means x1 and x2 both are independent, and each of them has PD of this. So what it means is I am taking a sample from the same population. So, for example, these x1 and x2 would be lifetimes of the bulb manufactured by a company. I have to find the distribution of y is equal to x1 plus x2, and hence using this I have to find the PMF or PDF of y. See that, let us consider the joint probability mass function of x1 and x2. Since they are independent, that is same as product of individual probability mass functions. Since they are identically distributed, fx1 is same as fx, fx2 is same as fx2. Now, fx1 is 2x1 if x1 is between 0 to 1, fx2 is 2x2 if x2 is between 0 to 1. So, that means fx1 into fx2 would be 4x1 x2 if x1 is between 0 to 1 and x2 is between 0 to 1, and this would be 0 otherwise. So, that is a joint probability mass function of x1 and x2. Support is because density is positive when x is between 0 to 1. So, support is of Sx is 0 1 cross 0 1, and since y is x1 plus x2, since support of Sx is 0 1 cross 0 1, support of y would be nothing but 0 2, close interval 0 2. So, I look at what is the distribution function of y fyx, which is same as probability x1 plus x2 is less than or equal to x. Since support of y is 0 2, so if x is less than 0, clearly fyx is 0. The right hand point of the support of y is 2, so for x greater than or equal to 2, fyx is 1. Now, let us try to see for x between 0 to 2, what is the distribution function of fyx. Fyx is probability that x1 plus x2 is less than or equal to x. So, what I do is I integrate the joint PDF over the range x1 plus x2 less than or equal to x. But my joint PDF in 0 to 1 cross 0 to 1 is 4x1 x2, and this is 0 otherwise. So, this integral becomes 0 to 1, 0 to 1, 4x1 x2, and I have to integrate it between in the range x1 plus x2 less than or equal to x. So, what I do is I first fix x1 as a free variable. X1 as a free variable can go from 0 to 1. Now, for a fixed x1, x2 is between 0 to 1 and x2 is also less than or equal to x minus x1. So, x2 is greater than or equal to 0, less than or equal to 1, as well as for fixed x1, x2 is less than or equal to x minus x1. So, these two quantities give me 0 less than or equal to x1 less than or equal to 1, x2 greater than or equal to 0 less than or equal to minimum of 1 and x minus x1. But for this interval to be non-empty, the right hand point should be bigger than or equal to left hand point. So, that means minimum of 1 and x minus x1 should be greater than or equal to 0. So, that means 1 should be greater than or equal to 0, which is always true, and x minus x1 is greater than or equal to 0. So, that may give me x1 less than or equal to x. So, that means the range of x1 for a fixed x would be x1 is greater than or equal to 0, less than or equal to minimum of x and 1. So, x1 as a free variable for fixed x can go from 0 to minimum of x and x1. Now, for fixed x1, x2 we have already seen can go from 0 to minimum of 1 comma x minus x1 and 4x1 x2. So, I have to integrate this quantity. So, of course, one had to break this range x between 0 to 2 in two parts, whether x is between 0 to 1 or x is between 1 to 2. So, when x is between 0 to 1, fyx turns out to be this, and this integral turns out to be x4 by 6. Similarly, for x between 1 to 2, if one goes to this integral, then x is bigger than or equal to 1. So, that means 1 is minimum. So, that this range becomes 0 to 1, and this is 1 to x minus x1. So, this range will become 0 to 1 and minimum of 1 to x minus x1. Now, note that here x1 is between 0 to 1, x1 is between 0 to 1. So, x minus x1 would be between x minus 1 to x. So, here it depends. So, I have to break this range into two parts. When x1 is between 0 to x minus 1. If x is between 0 to x minus 1, minimum of 1 and x minus x1 is 1. So, it would be 0 to 1, 4 x1 x2 plus x minus 1 to 1, and then in that case minimum of 1 and x minus x1 would be x minus x1, and then 4 x1 x2 dx2 dx1. Now, this is happening because what is happening over here is, here x minus 1 is always between greater than or equal to 0 less than 1. So, this quantity is between 0 to 1. So, I will have to break this quantity into two parts, 0 to x minus 1 and then x minus 1 to 1, and then if you do that I get two integrals in this form. If you simplify this, f(y(x) turns out to be this quantity, x minus 1 whole square plus 4x minus 3 minus x plus 3 x minus 1 whole cube divided by 6. So, I have found out f(y(x) in all possible ranges. So, my f(y(x) turns out to be 0 if x less than 0, x to power 4 divided by 6 if x is between 0 to 1, and x minus 1 whole square plus 4x minus 3 minus x plus 3 x minus 1 whole cube by 6 if x is between 1 to 2, and 1 if x greater than or equal to 2. Now, clearly if you see this distribution function, this is differentiable everywhere except possibly at the points 0, 1 or 2. And if I see f(y) prime x, f(y) prime x turns out to be this quantity. So, this is 4x cube by 6, which is 2 by 3x cube if x is between 0 to 1, 2x minus 1 plus 2 by 3, 1 minus x plus 2x minus 1 whole square if x is between 1 to 2. Rest of the places I can make it 0, and one can easily check that minus infinity to infinity f(y) prime x dx is 1. So, it turns out that random variable y is of absolutely continuous type, and its PDF is given by f(y(x), which is given over here. So, in this case what we did was, first we find out the distribution function of y, and using the distribution function phi we saw that it is absolutely continuous, and hence we could find the PDF. Let us consider another example. Let x1, x2, x3 be a random sample from a distribution having probability mass function given by this function, which is 1 by 6 if x equal to 1, 2, 3, 4, 5, 6 and 0 otherwise. So, what it means is x1, x2, x3 are independent, and each of them have the same PDF which is given by this quantity. So, what it means is x1, x2, x3 are sample observations from the same population, and these observations have been taken independently. And suppose I am interested in finding the distribution of minimum of x1, x2, x3. So, what is being suggested is first find the distribution function and hence find the PMF of y. So, let us try to see what is the distribution function of y. So, for x belonging to R, f(y(x) is probability y less than or equal to x, which is same as probability minimum of x1, x2, x3 less than or equal to x. Minimum of x1, x2, x3 less than or equal to x is equivalent to saying that at least one of them is less than or equal to x. So, what I do is I write down this in terms of its complementary event, which is same as 1 minus probability that minimum of x1, x2, x3 is greater than x. But you know that if minimum of certain quantity is bigger than fixed quantity, if and only if each of them is bigger than that fixed quantity. So, minimum of x1, x2, x3 would be greater than x if and only if each of them is bigger than x. So, that means x1 greater than x, x2 greater than x and x3 greater than x. But x1, x2, x3 are given to be independent. So, probability x1 greater than x, x2 greater than x and x3 greater than x would be same as probability x1 greater than x multiplied by probability x2 greater than x, probability x3 greater than x. But each of them have the same PMF. So, that means these all three quantities would be same, because x1 has the same distribution as x2, x2 has the same distribution as x3. So, that is why this would be same as 1 minus probability x1 less than or equal to x, which is 1 minus fx whole cube. So, where f is the distribution function of x1, and how the distribution function of x1 looks like. I know that x1 takes value 1 to 6 each with probability 1 by 6. So, I know the distribution function of x1, which is fx, clearly would be 0 if x is less than 1, if x is greater than or equal to 1, less than 6, and x is an integer, then in this case it will turn out to be maximum integer contained in x divided by 6, and 1 if x greater than or equal to 6. So, this is what the distribution function of x1 looks like. So, that means if f x is 0, if x is less than 1, if x is between I to I plus 1, this is I by 6, this is 1 if x is greater than or equal to 6. So, my f y x turns out to be 0 if x less than 1, 1 minus f x whole cube, which is 1 minus I by 6 whole cube if x is between I to I plus 1 for I is equal to 1 to 5, and this would be 1 if x greater than or equal to 6. So, this you get from the last expression which we got, which is 1 minus f x whole cube, and we know f x is given by this. So, f y x, which is nothing but 1 minus f x whole cube, will be given by this quantity. So, clearly this is a step function. It has jumps at the point 1, 2, 3, 4, 5, 6. So, that means y is a discrete type and its support is 1, 2, 3, 4, 5, 6. And what is f y x? F y x is probability mass function at point x is f y x minus f y x minus. Now, if x is 1, 2, 3, 4, 5, 6, in this case f y x minus is nothing but f y x minus 1. So, this f y x minus 1 turns out to be 1 minus x minus 1 by 6 whole cube minus 1 minus x by 6 whole cube if x is from 1, 2, 3, 4, 5, 6, and this is 0 otherwise. So, what we saw is sometimes it is easier to find out the distribution function, and using the distribution function one can find out the probability mass function or the probability density function.